welcome to Really.
Yes, with Tom and Dave.
Yes,
And
he's the Dave part.
And we have a rather extraordinary guest.
Extraordinary indeed.
Exciting. More extraordinary could mean a lot of things.
Well, exciting and extraordinary, but yeah. I think both are, worthy for this gentleman here. Avi Loeb is the Frank B. Baird Jr. Professor of Science at Harvard University and a best-selling author, New York Times, Wall Street Journal, Publishers Weekly. He received a PhD in physics from the Hebrew University of Jerusalem in Israel at age 24, led the first international project supported by the Strategic Defense Initiative, and was subsequently a long-term member of the Institute for Advanced Study at Princeton. Loeb has written 9 books, including most recently Extraterrestrial and Interstellar, which is right here, which is fantastic, as well as over 1,000 scientific papers on a wide range of topics, including black holes, the first stars, the search for extraterrestrial life, and the future of the universe. Avi Loeb is the director of the Institute for Theory and Computation within the Harvard-Smithsonian Center for Astrophysics and also serves as the head of the Galileo project. He has been the longest-serving chair of Harvard's Department of Astronomy and the founding director of Harvard's Black Hole Initiative. He is an elected fellow of the American Academy of Arts and Sciences, the American Physical Society, and the International Academy of Astronautics. Avi Loeb is a former member of the President's Council of Advisors on Science and Technology at the White House, a former chair of the Board on Physics and Astronomy of the National Academies, and a current member of the Advisory Board for Einstein Visualize the Impossible of the Hebrew University. He also chairs the Advisory Committee for the Breakthrough Starshot Initiative and serves as the Science Theory Director for all initiatives at the Breakthrough Prize Foundation. In 2012, Time magazine selected Avi Loeb as one of the 25 most influential people in space. And in 2020, he was selected among the 14 most inspiring Israelis of the last decade. We are thrilled to have him here on Really. Thank you for giving us your time, sir.
I hope we still have some time now.
Yeah, well, hey,
Well, you could have saved some time by calling me a curious farm boy.
Okay, okay.
I was born on a farm, and I'm just curious. That's all.
Yeah.
Well, I first of all, this was such an interesting read, such a great conversation about the future, about what's happening right now, and if the universe is filled with ancient civilizations, some might say, well, where are they? Now, it seems like Interstellar might say, well, we haven't been looking.
Right.
Or at least not looking in the right way.
Right.
Describe to us the Galileo project and what its key objectives are.
Well, about 70 years ago, Enrico Fermi sat at lunch in Los Alamos and asked, where is everybody?
Right.
It sounded reasonable that, there are tens of billions of other stars like the sun. They might have planets like the Earth. In fact, today we know that a significant fraction of them, somewhere between a few percent up to almost most of them, may have a planet the size of the Earth, roughly at the same separation. So it sounds reasonable that there were others before us, that Albert Einstein was not the smartest scientist who ever lived since the Big Bang, 13.8 billion years ago. So Enrico Fermi asked, where is everybody? Now, to me, that is not a satisfying question because it's just like standing at home and saying, I don't see anyone around me. I don't have any partners. But we all know that to find partners, you have to go on dating sites. You have to look at least through your window. You need to check your backyard if there is any tennis ball thrown by a neighbor. I mean, you can't just say, where is everybody?
Right.
And Enrico didn't really look through telescopes. He didn't really search. And space is vast. Time is very long, measured in billions of years. So to imagine that you would see with your naked eyes someone next to you that will tell you that you have neighbors is not really, a professional approach to the subject. And since then, of course, some people reported seeing unusual things, but it was never addressed scientifically. And so 2.5 years ago, I decided to lead the Galileo project. And its goal is to search scientifically for systematic evidence, meaning using instruments that we have full control over and monitoring the sky or going after objects that came into the solar system from outside and trying to figure out their nature, whether they are natural or maybe artificial in origin, because we sent 5 probes out of the solar system. They haven't left the solar system yet. It will take them 10,000 years to leave the outskirts, the Oort cloud.
Right.
Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and New Horizons. And, after they leave the solar system, they would become space trash. We are polluting our cosmic neighborhood. But others could have existed billions of years before us. And it takes less than 1 billion years for a Voyager-like spacecraft to move from one side of the Milky Way galaxy to the other side.
Okay.
And so there was plenty of time for that trip to have been made by a gadget from another civilization. And we just haven't checked our neighborhood for objects that are different than rocks. In fact, we only found the first few objects over the past decade. And guess what? The first two appear to be different than the rocks that we're familiar with. And so I said, well, that's intriguing. Let's figure out if they're artificial or natural. My colleagues say, how dare you even bring up this possibility? It's an extraordinary claim to even consider something like us. And I say, no, just read the news every morning. We are not that intelligent after all. We are probably in the middle of our class of intelligent civilizations in the Milky Way, and we can benefit from seeing a smarter student in the class that we can learn from. And why would we assume that we are unique and special? That's very arrogant.
Mm-hmm.
Let's just check if someone else preceded us. And it's not actually that someone that we will find. We will find whatever space trash that someone produced. And it's an opportunity for us to get inspired, to learn from others, because, as of now, we are really wasting a lot of effort on destructive measures. There are 2 wars going on right now, and I think there is room for improvement, for humanity to behave more intelligently and work together, because after all, we are all in the same boat, the Earth, sailing through space, and we better work together towards a prosperous future.
Yeah. Now, I'm wondering, when you decided to, because it seems like a very rational and even a modest question to ask.
Right.
Did you anticipate the level of hostility that would come at you from your peers?
No, because to me it sounds like a question that the public cares a lot about, and that's why there was so much attention to what I'm doing. After all, science is being funded by the public through taxpayers' money. So what happens often among scientists is they say, we are not supposed to take risks, because if we take we adopt risky propositions, then we are wasting taxpayers' money. But my point is, have you asked the taxpayers what they want to spend the money on? And if you were to ask, you would realize that it's not on, searching for the nature of the dark matter. We don't know what 83% of the matter in the universe is. And a lot of money is being dedicated to that. The Large Hadron Collider that cost $10 billion was searching for the lightest supersymmetric particle as the candidate for dark matter. They haven't found it. My point is, if you just allocate 1% of that budget to the search for technological objects near Earth, we could make a huge amount of progress. That's 1% of what was allocated to a question that the public doesn't feel affects our future as much as finding whether we have a partner. So, the study of dark matter is in the context of the study of the universe, cosmology. And one of the most famous cosmologists of the 20th century that got a Nobel Prize in physics, his name is Steven Weinberg. And he argued at the end of his book, The First 3 Minutes, he said, the more we comprehend the universe, the more pointless it looks. And I say, yeah, in fact, if you poll cosmologists, they will tell you there is no point. There was a Big Bang, things evolved this way. It's a consequence of the laws of physics. There is no point. But I say you're missing the main point, because if we know from our private life that if we were to find a partner, it gives meaning to our existence, right? Finding a partner in your life. So these cosmologists focus on lifeless entities like particles, radiation, stars. And I say that if we find a partner in interstellar space, among the stars, then it would give a meaning to our cosmic existence. That would be a huge reward. And moreover, it will educate us about the kind of technological future that awaits us, because we had only 1 century of science and technology. And we discovered quantum mechanics just a century ago, and we are using it in all our gadgets. So imagine what we might know 1,000 years from now, or 1,000,000 years from now. And this might have been learned already by others. So by witnessing what they produced, we could get a sense of what our future might be like. And, a very advanced technological civilization could be an approximation to God. Why? Because just think about the biblical story from the Old Testament of Moses finding the burning bush. The burning bush was not consumed, and that convinced Moses that it was produced by a superhuman entity that he called God, that he believed in. Nowadays, you can probably buy off the shelf some gadget that would behave in ways that would look completely, like the burning bush. So if I were next to Moses, of course, I would use the infrared cameras of the Galileo project to inform Moses as to how much energy per unit time is emitted by this bush, whether it's natural or was produced by some superhuman entity. But what I'm trying to say is that a very advanced technology, if, for example, you imagine a cave dweller coming to New York City, it would look as a miracle to the cave dweller, and the cave dweller might have religious awe looking at those gadgets. So, in fact, finding another civilization far more advanced to us would fill us with awe, and it would be a way of bringing together religion and science in some sense, because religion is all about the appreciation of something bigger than you that exists out there. And that role could very well be filled by a far more advanced technological civilization, and that could, for example, produce life in the laboratory, or could produce even a baby universe if they understand how to unify quantum mechanics and gravity. So what I'm saying is, for the future of humanity, it would have a huge impact. For the future of religion, it would have a huge impact. So how can scientists ignore this potential?
Mm-hmm.
And how can they be so negative about exploring it? Because all I'm saying is, we exist next to the sun. There are so many stars like it, with planets similar to Earth that could have had a civilization like ours a while ago, billions of years ago. So the whole point is to check. So why is that so controversial? People say it's an extraordinary claim. I say, no, it's an ordinary claim. Actually, arguing that we are unique and special is extraordinary. It's arrogant. And following the scientific method and trying to figure out if there is a package in our mailbox or in our backyard, that to me sounds like common sense.
Mm-hmm.
But common sense is not common.
To that end, well, first of all, Raiders of the Lost Ark is my favorite movie of all time.
Mm-hmm.
I think there's total logic to the idea that if there is archaeology on it, when you say something like interstellar archaeology, I lean in, because that sounds, first of all, super cool, and it makes total sense that if there is all of these worlds, then why wouldn't we be seeing Diet Coke cans of theirs flying by, or why? So I guess my question is, how do you specifically look for this material? Can anyone be an interstellar archaeologist? Is there material potentially around us in the ground? Like how do you look for this kind of material?
Right. So actually there is a documentary being made about my work, and there were more than 50 filmmakers and producers that wanted to follow my work, because in summer 2023 I went on an expedition to the Pacific Ocean.
Yes.
And the documentary,
I heard a bit about it.
Yes, and we want to hear more.
They actually filmed me giving the last class at Harvard before going on the expedition.
Oh, wow.
In the spirit of Indiana Jones. They got me a hat which looked a bit different than that of Harrison Ford, but there are some parallels in the sense that I'm a scientist. In fact, I'm a theoretical physicist, so I worked for decades in the realm of ideas, but here I noticed that nobody is doing it, so I have to do it myself, and I have to embark on an expedition to collect materials from an object that most likely came from outside the solar system.
You tracked this object, right? It blew up in our atmosphere.
Right.
And by its trajectory, you knew it was an interstellar object?
Yeah, so...
were you the one who identified it as interstellar?
Together with my student, Amir Siraj, the undergraduate student I had. So what happened was that this object was detected by US government satellites back on January 8th, 2014. And 5 years later, I was asked by a radio station to have an interview on a meteor that landed near Kamchatka. And in the process of getting more details about this meteor from the internet, I realized that there is a catalog of meteors that NASA compiled over the past decade or so. And it includes not only the dates, but also the speeds of those meteors, the velocity that they came and collided with Earth at. And so I asked my student, I said, look, let's check if any of these velocities are high enough for one of these objects to not be bound by gravity to the sun. If an object is moving near the sun fast enough, it cannot be kept tied up to the sun. That's the way that rockets escape from the gravitational pull of the Earth, right? So he checked, and we found this particular meteor from 2014 that indeed was moving not only faster than the escape speed from the sun, but was moving outside the solar system at 60 kilometers per second, faster than 95% of all stars in the vicinity of the sun relative to the local frame of the Milky Way galaxy. So that was intriguing. Here is an object that came from interstellar space. And we submitted a paper for publication, but the reviewers declined and said, we don't believe the US government data. And so it took me 3 years to convince people within government, through the White House. Eventually it got to the US Space Command that issued a formal letter to NASA stating that they checked the data, and indeed this object is moving too fast to be bound to the sun. It's interstellar at the 99.999% confidence. At which point our paper was accepted for publication. But the government also released data about the fireball, the light that was emitted as a result of the friction of this object with air when it exploded. And from that, we concluded that the object was tougher than all space rocks in that catalog of NASA, 272 of them. And so that raised the possibility that it may be a Voyager-like meteor. Just imagine our own spacecraft Voyager colliding with a planet like the Earth. In the future, it would burn up as a meteor in the atmosphere of this planet, but would have an unusual material strength because it's made of an artificial alloy, an unusual speed because it was propelled by a chemical rocket.
Would that come from like a spectroscopic analysis of it?
No, it's just the speed of the object and the fact that it disintegrated only under a much larger stress than all natural rocks from the solar system. So it was able to maintain its integrity. Yeah, exactly.
Yeah, so I was wondering.
Because we knew where it exploded. It exploded at the lower atmosphere at an elevation of 20 kilometers above the Pacific Ocean. So very low in the atmosphere, the density of air is high, and it was moving very fast. And from that, we concluded that it was able to sustain stress from the friction with air far greater than any other stone that was cataloged by NASA over the past decade. So I decided to lead an expedition to go there and assembled 28 team members, some of the best navigators, engineers in the world for such expeditions. And the other challenge was to raise $1.5 million. This was an expensive mission. And a few months after I announced it, a donor came along and organized a Zoom call with me and said, you have the money? And so we went there. We built a machinery. We built a sled with magnets on both sides. And
Because this blew up completely. As far as you know, I mean, it's very small particles.
Well, we don't know how big it was, but we know that at least 500 kilograms of material were evaporated in this explosion.
Mm-hmm.
And it could have been from the surface of the object, it could have been the entire object. If it was the entire object, then the size of the object was roughly that of a watermelon, half a meter or so. But it could have been the outer layer. And at any event, we were looking after those molten droplets that evaporated from the surface of the object when it was exposed to the immense heat from this fireball. And the fireball released a few percent of the Hiroshima atomic bomb energy. So that was a huge amount of energy near Papua New Guinea. And so we rented a ship that was fittingly called Silver Star and decided to go there and look for the materials. The ocean depth is 1 mile, and the region that the Department of Defense localized for the meteor site was 7 miles on a side. So we were going to explore this huge region and look for molten droplets the size of a grain of sand, less than a millimeter in size, at the bottom of the ocean, a mile deep. It sounded like an impossible mission, but we did find it.
Yes. Yeah.
You found it. So what does that mean when you find when you brought it up? Did you know? Did you have to study it after? What was?
Yeah. No. So we had a sled roughly the size of a person that had magnets on both sides, and whenever we brought it to the deck, we had to scrape the magnets and collect the magnetic particles, most of which were black powder, volcanic ash from Earth. And for the first 6 days, that's all we noticed. But then we decided to filter out the tiny particles of volcanic ash. And we were able to then isolate the bigger particles and put them under a microscope. And lo and behold, we found the first spherule. It looked like a metallic marble, very distinct from the background sand. And the moment that one of the team members showed it to me on the image of the microscope, I hugged him because I realized if we find one of those, there must be many more. Just like when I find an ant in the kitchen, I get alarmed. I know there are many more. So we found 50 of them, of those spherules, on the ship. And then I shipped the material back to my home with FedEx and brought it to the laboratory of my colleague at Harvard, Stein Jacobson, who is a world-renowned geochemist, and he has a mass spectrometer that can analyze the composition of those spherules. And I had also during the summer, after we came back, it was 2 weeks in the ocean, in the sea, and then at the end of June we came back and I brought the materials, and I had a summer intern that was shadowing me because she had an ambition to become a science journalist. And at one point she said, "Can I help doing the science?" And I said, "Of course," and gave her tweezers and arranged for a microscope. And she found 600 more of those spherules. Nice. Her name is Sophie Bergstrom. So I gave her the honorary title of the Spheral Hunter.
Yeah.
And then by now we have about 800 of them. And so far we analyzed 7% of those, but we are about in the coming weeks to analyze the remaining 93% of the spherules. And just from analyzing a small fraction of them, we already found a special type, a unique type of spherules that has composition of elements that was never found before. And we think that it might represent material from outside the solar system because it has elements like beryllium, lanthanum, uranium, which are hundreds of times more abundant in those particular spherules that were found near the meteor path. We found an excess of spherules there. We made a map of the spherules and we found an excess along the meteor path and found a unique type of spherules never seen before, which we call Belau. We gave it a name because it was never discussed before. and Belau is to indicate that beryllium, lanthanum, and uranium are very abundant. And now we have a chance of increasing the sample by another factor of 10 in the coming weeks by analyzing the rest of the spherules. So altogether, I would say the lesson from this is that it's important in life to be an optimist, because sometimes life is a self-fulfilling prophecy. If you don't search, you will not find anything. A lot of people said, why would you go there? There is nothing for you to find. First of all, maybe the government was wrong. Maybe there weren't enough spherules for you to find. Maybe we will not find anything unusual. It could have been that my colleague at Harvard would have no time to help in the analysis. But my point is that we made it in a way, and that was very rewarding. And it's not identical to the way that the Indiana Jones finds things. I mean,
well, you didn't have a whip.
Yeah, I mean,
Well, there were no Nazis
No.
in that narrative, but there were very hostile people in the academic community.
Yeah,
we won't go that far with that, but yeah, that's it.
But it does seem like there was even resistance to acknowledging that it was an interstellar object.
Oh, yeah.
Whether manufactured or naturally forming.
Yeah, when on the day that I returned from the expedition, there was a paper published in the Astrophysical Journal by two astronomers who argued that the US government doesn't know what they're talking about, that this must be the speed that they measured must be 3 times smaller because they cannot fit the data with their model for stones in the solar system. And I call that the Stone Age of science, where everything in the sky must be stones of the type that we had seen before. My point is, if it came from outside the solar system, it may be different than your model.
Right.
And you have to be modest enough to allow nature to educate you about something new. I mean, if those people would look at data on dark matter, they would argue we can't fit the data on dark matter with stones, therefore the data must be wrong.
Right.
That makes no sense, because there is a whole field with hundreds of people working in it, trying to figure out what the dark matter is. So you can't just argue that if your model doesn't fit the data must be wrong. And especially when dealing with the US Space Command, which gets more funding than NASA, and is supposed to advise the US president whether a ballistic missile is heading from North Korea towards Washington, D.C. If they get the measurement wrong by a factor of 3, they would alert Mexico for a missile heading to Washington, D.C.
So when you're looking at the composition of these spherules, and you're now feeling like, okay, this is unique, it could be from very, very far away, does it tell you anything about, could this be created by intelligence?
Well, not yet. Just the composition is not conclusive as to the origin. We came up with a possible explanation that is natural, which is if a planet like Earth came close to the most common type of stars, dwarf stars. The nearest star to the sun is a dwarf star. It's Proxima Centauri, 12% of the mass of the sun. Most stars are 1/10 of the mass of the sun. And such stars are 100 times denser than the sun because they have 1/10 of the mass of the sun, but they're also 1/10 of the size of the sun. So the mass per unit volume is actually 100 times bigger. Now, if you were to take the Earth, we are all familiar with the tide that the moon raises in the oceans. Imagine replacing the moon with the sun, or even bringing the sun very close to Earth. It would still not be strong enough. The gravity would not be strong enough to break the Earth apart. The tide that the sun can produce is not big enough because the mean density of the sun is less than the density of rock that the Earth is made of. But a dwarf star is 100 times denser than the sun. And so if you bring a planet like the Earth close to such a star, it would get ripped apart. And it would get spaghettified, basically, generate a stream of rocks, half of which gets ejected to interstellar space at a speed that is similar to that observed for this meteor. Okay. So this is a natural possible origin, but it's also possible that it may have been a spacecraft. And the way to figure it, obviously a spacecraft would also have unusual abundances of elements. For example, imagine a computer screen or a semiconductor being melted when you put it in a fireplace. The droplets that you will get out of it will have abundances that are quite different from those of natural rocks.
Mm-hmm.
So to tell the difference between an artificial object and a natural object, you really need a big piece of the object.
Right.
So we are currently thinking about the next expedition, planning it, and the goal would be to build machinery that would collect bigger pieces. We now know where to go because we found those spherules. So that would be really exciting. And in the last class of the spring semester of this year, I asked students in my class, if we find a technological gadget and it has buttons on it, should I press a button? And half of the class said, no way, please don't do that, because it will affect all of us.
Mm-hmm.
And the other half said, please do, because who knows, maybe it's ChatGPT 100, we can see what it does. And then one of the students raised his hand and said, given the split vote, Professor Loeb, what would you actually do? And I said, I will bring it to a laboratory and examine it before engaging with it. Now, a couple of weeks ago, I went to dinner in New York City. It was hosted by Bill Ackman and Neri Oxman. She is an inventor, he's an investor. At any event, General Petraeus was in that dinner, and the question arose as to what would be the geopolitical future of the Middle East after the war between Israel and the Hamas will end. And he expressed his view, which was not necessarily uplifting, I would say. But among the group of people around the table, there was also a more hopeful view that was expressed by the curator of the Museum of Modern Art, Paula Antonelli. She summarized it in 3 words: love the aliens. And then Neri Oxman said, Avi, you are here. What do you make of it? And of course, what Paula said is that we are usually afraid of something that is different than us. We are hostile to it. But if we adopt a different approach where we actually love something that is different than us. In my case, I would love actually members of another civilization who are smarter than us. Why should you be afraid? Why should you have an inferiority complex? You can learn from them. So love the aliens appeals a lot to me. And I am approaching it in a scientific way. I'm trying to find those that I want to love, those aliens. And I promised Paula Antonelli that if I find any such gadget, I'll bring it for exhibit at the Museum of Modern Art. Because even though it may be ancient history in terms of the senders of that gadget, it would be modern art for us.
Now, you probably spend more time around scientists than we do.
That's fair.
And I think I'm pretty... Yeah.
And I survived.
Yeah, you're not going out on a limb there.
You might want to ask, how did I survive?
Well, yeah, I'm curious as to, do you have any theories about why there is such an antipathy to thinking about these things?
Well, there are several aspects to it. One, that there is a long history of people in the general public making claims that are not substantiated. And so scientists shy away from it because they want to work on a subject where they don't need to satisfy the appetite of people in the general public. They don't need to be scrutinized. And so they can do it as an intellectual pursuit without getting this constant scrutiny from the public. And so they choose to work on esoteric problems very often. And at the same time, they argue that what the public advocates is not scientific, it's not substantiated, and it's therefore does not merit any study. And I say that's not a healthy approach. In fact, there was a view maybe 1,000 years ago that the human body has a soul, okay, and therefore it shouldn't be operated, shouldn't be dissected, because it would hurt the soul if you open the human body. Now imagine scientists saying, "Oh, this is nonsense, but we don't want to work on that on the human body because immediately all these people will come to us and start bugging us if we were to." So then, where would modern medicine be if we? So my point is, you actually have to confront these issues, and even if people are saying the wrong things, even if they report about things that are not substantiated, you can study those things. You can study the human body in a scientific way, and the whole modern medicine came out of that. And the life expectancy of people, increased dramatically as a result of modern medicine. So there are benefits to that. So there is no scientific subject that is more important for the future of humanity than the question of whether we have a partner out there that we can learn from. And so that's one aspect of it. The second is, we always wanted ourselves to be the central actor in the cosmic play. And so we argue that we are at the center of stage, center of the world, for 1,000 years after Aristotle. And then when Galileo Galilei claimed that otherwise, he was put in house arrest, so people would not listen. It didn't change the fact that the Earth moves around the sun, okay? And it's to our benefit to know that, because otherwise we would never launch spacecraft that would reach Mars, for example, because we would think that Mars moves around the Earth. It wouldn't. So it's really important for us to adapt to reality the way it is and not the way we imagine it to be. And we tend to imagine ourselves as important. That's why we're asking, where are they? I mean, as if we are the center and they should come to visit us, obviously, because we are so important. And I say, we are not more important than a colony of ants on the pavement for a biker that passes by. Why would they care about us if, especially since our science and technologies are just a century old? Most of the time we were not very different from animals. And so I don't see ourselves as unique and special and the pinnacle of creation. I can imagine a lot of room for improvement. And in fact, we were the most intelligent on Earth until now, but now AI might replace us in that role, and that should give us a sense of humility. So the second point is, we prefer to believe that we are special, unique, the smartest, not only on Earth, but in the universe, and nothing like us existed or exists. And I say, that's arrogant, okay? So that also is in the back of the minds. And of course, there is also always the claim, extraordinary claims require extraordinary evidence, without seeking the evidence. That's what the scientists are not doing. And so it's a circular argument. Because if you were to say the same about gravitational waves, you would say, I haven't noticed any gravitational waves, but you have to invest $1 billion in the LIGO experiment before you notice them. And the same is true of any advance in science over the past couple of decades. We had to invest huge sums of money. So you can't just say, there is no extraordinary evidence, therefore I don't want to work on this, which is pretty much what they're saying. So I'm trying to break this mold. Now, the problem is not only these people are not doing any active work, they're pushing back, ridiculing, arguing that there is nothing to be found in the Pacific Ocean. After I bring the material, nothing was found in the Pacific. It's just, the latest argument is that it's coal ash. It's fly ash. And everyone was jumping up and down saying, oh yeah, we knew it. There is nothing new. In fact, they found technological materials, but made by us. Oh, how ridiculous that is. And I just had a team meeting last evening to examine this argument. And we plotted the abundances of elements, like especially iron. The spherules that we found, the Belau spherules, are mostly iron. And coal ash has very little iron. And if you look at other elements like aluminum or silicon, it's very distinct from the spherules that we found. You can't confuse the two at all. And that is obvious in retrospect because we used magnets to collect the spherules. So coal ash would not stick to magnets. And so how would people even bring this up and write a scientific paper about it and write a blog that was circulated among hundreds of thousands of people, and everyone was jumping up and down.
And
I say that just shows you how non-professional this practice is of the critics. And I say these critics are no different than spectators looking at a soccer match and telling the players how to pass the ball. How dare they? We have the materials. We analyzed only a fraction of it so far, and they already make an argument as if we found collage, which...
And how much of your sample material did you give them to study in depth?
Nothing.
So they had no samples?
They had no sample. They just relied on our analysis of 7% of the spherules.
Yes.
And they didn't even take into account that we collected them with magnets. So...
But it's easier than going to Papua New Guinea and going a mile underwater. So
that's
just
the whole point.
Yeah.
That you have these pretenders that argue that they are protecting science.
Yes.
They're pro-science. And some of them are bloggers that are well-known, science popularizers that are well-known. And if you check their record, they haven't published a single scientific paper over the past decade. In fact, one of them, I mentioned that he did not publish a single scientific paper over the past decade. So he noticed that. I didn't even mention his name. And he put it on his Twitter handle as if it's a label that he's proud of. So he's proud of his incompetence. The fact that he dropped out of academia is something that is a feather in his cap. And my point is that those who value incompetence will not terrorize real scientists. This point I want to make clear, that those who do the hard work of planning an expedition for months, going to the Pacific Ocean for 2 weeks, collecting materials day and night, bringing the materials to a university, using the best instruments in the world to analyze the material for 5 months by now, will not be terrorized by someone who sits on his chair and makes critical comments, ridicules this study, and everyone who was not part of the exploration obviously cheers because they're jealous of the attention that it gets, of the success of the expedition. And to me, it's really sad to see this happening because we should all be curious. My question is, why is childlike bullying more prevalent than childlike curiosity?
So my question is, as I said, I understand that some scientists not taking an interest in this area of non-human intelligence or possibility of non-human technology, and just not taking interest in, or even maybe not taking it seriously. It's the level of anger and the hostility and the amount of energy that gets put into not just criticizing, but it seems like there's a desire to destroy a scientist like yourself,
right,
who is taking the subject seriously.
Right.
And I think you've...
But you see it in kindergartens, right? Whenever there is a child who is different than the rest, that child is often bullied and pushed into a corner. And the tactics is really simple. The tactics is to push the child as much as possible such that at some point the child responds. And at that point you say, oh, wait, he just did something. We can now kill this child.
Yes.
And I therefore decided about a different strategy. First of all, I don't respect those critics who make no sense with my attention. And second, I adopt the strategy of the eagle. Very often the eagle has a crow on its back that is pecking at its neck. And the eagle, rather than fighting off the crow, the eagle rises to greater heights where the oxygen level is low and the crow cannot survive and just drops off. And so to me, the greatest heights are those of the best practice of science, where the oxygen level of those bloggers, pro-science pretenders, they cannot survive on that level of oxygen.
Yeah.
But it's really unfortunate that this exists because it suppresses innovation. It suppresses the ability to learn something new.
And it seems very specific to this issue, though. it's very, very specific in that I'd say most other issues that are maybe a little esoteric or on the cutting edge of science, if someone like yourself, someone as accomplished as yourself, with a long history of a proven track record as an excellent scientist, comes in and takes an interest in the subject, any other subject at all, people would go, oh, I've never really thought seriously about that, but if Avi Loeb thinks this is an important thing to look at, we should all take it seriously.
Right.
But with this issue, the attitude seems to be, well, if someone as accomplished as Avi Loeb is taking an interest in this, he must not be all that accomplished anyway.
Right. Well, I see a constructive way of resolving this, and that is finding clear evidence that nobody can deny.
Mm.
But you can see that in the attempt to collect that evidence, there are all these people who jump at me and try to suppress it, even before we analyzed it. But my belief is that, if we get a high resolution video of an object with the Galileo project that is moving in ways that our technologies cannot reproduce, and it looks artificial in origin, or if we find a gadget at the bottom of the ocean that was not produced by our civilization, then obviously there will be no way out of the conclusion that it's real. And so that's my hope, that eventually the evidence will win the day, just as it did in the case of Galileo Galilei. And for that, I adapt two principles from sports. One of them is the principle of FIFA. In the World Cup of women, the decisions were not made by paying attention to what the audience says or what the players say. The decisions were made as to whether there was a goal or not using cameras, instruments that have no personality, no bias, not based on eyewitnesses, and so forth. And so this is the scientific approach, where you use instruments to record data and analyze it. And in particular, we will use machine learning, artificial intelligence, so that we don't introduce a human element to the analysis. And the second part is what basketball coaches often say: keep your eyes on the ball, not on the audience. So I have no footprint on social media. I don't care how many likes I get. It doesn't mean anything. What matters to me is where the ball is. And the ball right now is in the form of the evidence that we are trying to analyze.
To your credit, you advocate for transparency in your work. Has this pushback? I mean, I always say, like, the closer you're getting to something good, the more ferocious it's going to feel when it's coming at you, because there's just that friction that is inevitable and usually a very good sign. But has it caused you to go, like, maybe I'm not going to share as much, or maybe I'm not going to share the experience of discovery, which is exciting, which I think is to the benefit of people?
It didn't affect me, but it affected, of course, some team members that are very worried about, especially the young ones, they evaluate their prospects for getting jobs, and they're worried about the response. And of course, that is the reason that some of the attacks are being initiated, to send a signal to the young people not to deviate from the beaten path. And I think that's the worst. So in fact, I'm planning also to write a book for young people, young adults, that would encourage them to explore. Because I do believe that the future of humanity depends on us paying attention to evidence more than to opinions of people.
But which I think is fantastic, because there is a fairly long history of scientists who have tried to push this subject forward, who have been destroyed in the past. People like James McDonald, and even J. Allen Hynek was very much dismissed, and so that all went underground in, I guess, what they called the Invisible College.
Right. But I'm not familiar with all the circumstances, but the point is that I'm just following my curiosity, and I'm still a kid. One of the most traumatic experiences for me as a kid was asking a difficult question at the dinner table and noticing the adults in the room dismissing it because they didn't know the answer. They didn't want to show any weakness, that they are ignorant. And I decided to become a scientist because it's an opportunity, it's a privilege for me to answer the question myself using the evidence that I collect. So I don't need to rely on the adults in the room. And what I see is deja vu again within academia, people pretending to be the adults in the room and dismissing the question. And for example, with respect to one of these interstellar objects, Oumuamua, there was no cometary tail. And yet the object was pushed away from the sun by some mysterious force. So I felt like the child in Hans Christian Andersen's tale, the emperor has no clothes. In this case, Oumuamua is the emperor and the clothes are the cometary tail. I said, there is no cometary tail, it's not a comet. My colleagues say, no, it is a comet, but it's made of materials that are invisible. We can't see the tail. It's a hydrogen iceberg or a nitrogen iceberg. And, it felt like going to a zoo and looking at an elephant, and then the adults around me saying it's a zebra. It's just that the stripes are invisible. It's just not honest. It's if you don't see a cometary tail, a comet is defined by the tail that is visible. So then another person said, well, maybe the tail exists when we look away. When we didn't look at the object, the tail was there, but when we looked at it, the tail disappeared, which is like saying the zebra has stripes that appear only when you don't look at it.
Quantum zebra.
Yeah.
And that was published in the Astrophysical Journal, this claim. And then there was another claim that, it's a dark comet. And in fact, there are dark comets. So of course there are dark comets. These are comets that evaporate very little, okay? So if they evaporate very little, you don't see any cometary tail. The problem is that for this object, Oumuamua, to be pushed at the level that was observed, you needed to lose 10% of its mass, okay? 10% during its passage near the sun. It's a lot. This object was 100 meters in size. If it were to lose that much mass, you would see a cometary tail. It cannot be a dark comet. Of course, there are dark comets. The fact that there are dark comets doesn't mean that Oumuamua could have been dark, because the acceleration that they experienced was extremely small, orders of magnitude small. Yet again, a scientist would say, well, there are dark comets. Of course, there are objects that don't even evaporate at all. But the point is that Oumuamua was pushed, and to push it with a cometary tail, you need a huge amount of material that would make it visible, given the levels of dust, water, vapor, carbon-based molecules that are associated with any comets that loses so much mass. And so I'm just trying to be as honest as possible, and people are saying, no, it's a hydrogen iceberg, it's a nitrogen iceberg, things that we've never seen before. And I say, if we've never seen them before, why not allow an artificial origin? They say, no, it must be natural. And then they change their mind from month to month as to what natural means. And that has been the case for 5 years. Now, after 5 years, there was even a blog post by a few scientists, a few astronomers saying, well, actually, there is no problem at all. And I say, if there is no problem at all, how come there are all these papers that were written by multiple groups trying to explain it as a hydrogen iceberg and nitrogen iceberg? So there are lots of layers of cover-up. And all I can tell you is that I'm saying what is obvious. It's not as if I'm inventing a story.
Right.
Yes.
And yet
and
it's
other
being
people are
resisted.
inventing rather outlandish explanations.
Now, of course, you might say, okay, well, Avi says that maybe it was pushed by reflecting sunlight. I don't believe in this interpretation. Fine, but the point is this object was unlike the rocks we have seen before. So it's intriguing.
This was, and Oumuamua, just for our audience, was the inspiration.
The
You wrote
inspiration
extraterrestrial for
exactly.
it, for the inspiration for Galileo project, right? Because we didn't have the means, we couldn't land on it and study it.
Right.
We didn't have the means of really analyzing it because we were looking for different things, planet killers, the whole thing. It's now flown past. We're not going to see it again.
Millions of times fainter than.
But we are looking for interstellar objects now.
Well, there is the Rubin Observatory that will start operations in the beginning of 2025 that has a 3.2 billion pixel camera, 1,000 times more pixel than in your cell phone, that will survey the southern sky every 4 days and will find many Oumuamua-like objects every year. Okay, so we're waiting for that. And amazingly, when I checked if anyone is designing software to identify interstellar objects out of the data stream that will come freely out of this telescope, I was told, no, we are just looking for objects bound to the sun. And that was shocking to me, given that Oumuamua was discovered. So with my postdocs, we designed the software. We are hoping to analyze the data within a year and a half and possibly get my. I was asked by a reporter, what is my biggest hope, wish, is to have as much data as possible about such an object, because, if indeed it's a nitrogen or hydrogen iceberg, we learn something new about an environment very different from the solar system that produced it, because we don't see such objects in the solar system. But if we have enough data, we could also tell whether it's natural or artificial, and that's what I want to figure out. So even if 1 out of 100 objects happens not to be a rock, that would change the future of humanity, and that's worth it.
Yeah.
These are clues that can save our species. These are clues potentially from other civilizations that if there was something in there that could just give us a hint, it could take our C-class civilization or D-class civilization to a C-class or some, it could give the push.
It would be a wake-up call for us.
And I think I remember an interview with you about maybe a year or 2 years ago, where you even just suggested that, if we're going to be looking at exoplanets, we should be looking for industrial pollution.
Right.
And that you got pushed back on that.
That was 2015. That was an idea that I had.
Yeah.
And now other people are talking about it. So, my hope is that in my lifetime, since this is a path that was never taken before, there might be low-hanging fruit. And in my lifetime, we will find something. And then, of course, the question is, what's next?
Yeah.
What's next for the Galileo project?
Yeah.
As of now, we're collecting data for about a month by now and using machine learning software to figure it out.
How many observatories have you set up?
We have one at Harvard University, and we're assembling a copy of it for Colorado. And then each copy would cost about $500,000, and it depends on how much funding we get as to how many we make. It would be good to have hundreds of them so that we get good statistics in many different regions on the type of objects that the US government claims they don't know what they are. I mean, a few percent of the unidentified anomalous phenomena are not figured out by the intelligence agencies. And to me, the role of a scientist like myself is to help government. If we find that they're made by Chinese or Russians, then we happily will give them the data. Send the data to Washington D.C. If we find very rare types of birds, we will happily give it to zoologists. But if it's anything else, that obviously the U.S. government doesn't care about interstellar affairs. They don't care what comes into the solar system from outside, and all of that is my focus. So we are complementary in our interest to the U.S. government that has a day job to protect the nation for national security. And therefore, I think it's a win-win situation. Whatever we find will be of value.
Are you looking to set up your observatories in areas that are sort of reported hotspots for activity?
Potentially, yeah, if we have enough of them. Yeah.
Places like the Hudson Valley and River
Potentially,
Valley.
yes. As long as they are not sensitive areas, strategic areas.
Yeah.
Are there any landing sites for meteors like the one that was in Papua New Guinea? Are there any new ones or places that you want to go invest there?
We identified as the second interstellar meteor that we think may have landed, and we consider the possibility of visiting that site as well. So we will have to make a decision in the coming months whether to go back to the first meteor and look for bigger pieces, or diversify our portfolio, since we collected some materials already from there, and look for material from the second interstellar meteor. So the second one is closer to Europe. It's a completely different path of a different ocean. And so we will decide where to go once we finalize the analysis of the spherules that we have. If they look very intriguing, we might say, okay, well, it's too tempting. We must go back again.
Oh, I see. Yeah.
So
Do you
it really
enjoy
depends.
being out on the open ocean?
Sorry?
Or do you enjoy being out on the open ocean?
No, I mean the boat rocks a lot.
I was wondering,
and-
as a Harvard scientist, how good your sea legs are.
Well, I jog every morning at sunrise on land. and
Which
I
stays
did it
fairly still,
also on the ship. And
Yeah.
I started, I monitor the speed that I jog at with a workout app that I have on my watch. And I noticed in the first couple of days that I'm actually jogging slower than usual. I thought it's jet lag. And then I realized, actually, what my watch is measuring is the speed of the boat. Because the GPS system is responding to the ship moving around. And so, I don't think anyone experienced that before, but actually, yeah, it wasn't a good measure of my speed. So I didn't sleep much during the 2 weeks because we would have those runs, 26 of them every few hours, and people would wake me up to collect the spherules or to scrape the magnets, and I was on all of the runs as we pulled out the sled from the because I was the chief scientist of this mission.
Mm-hmm.
So I felt responsible. I have to be there with my troops, so to speak. And altogether, I felt thrilled because it was a very fulfilling experience having a group of people that are all on the same boat and dedicated to the success of the mission. And to me, it gave a metaphor for how humanity should behave. We should all feel as if we should cooperate, work together, instead of investing, $2 trillion a year on military budgets. We could have spent it on launching probes to space. And guess what? If we were to do that, by the end of this century, we could send a probe towards every star in the Milky Way galaxy, billions of them, just by changing our priorities from killing each other to working together. But if you don't find cooperation within academia, which is supposed to be a heaven for cooperation, then how do you expect it in politics or among nations? So to me, perhaps the biggest impact that finding a partner out there would have is as a wake-up call to tell us, look, here is someone else that has different set of priorities that arrived to our doorstep long before we arrived to their doorstep. Isn't that inspiring? Can't we do better? It's just like seeing a student in the class that performs so much better than you do. On the one hand, you can get upset. You can say, I don't want to hear about that, which is pretty much what happens right now. But on the other hand, you can find inspiration from that student and learn how to do better, which is my hope.
I hope.
We're at the Soul Foundation this weekend, and you are speaking tomorrow, I believe, and we're excited to hear that. So I feel the need to ask you. We're going to hear a lot of things tomorrow, and a lot of claims, and a lot of people talking about what's going on in the government and these hearings and reverse engineering programs. What are your feelings about what we've been hearing about potential craft that is here, and what are your thoughts?
Well, it's intriguing. I haven't seen any of it, so I don't know whether to believe it. I want to see it before I believe it. But it's intriguing that there is this talk by serious people. And my hope is that if such materials exist or information exists, that it would be shared with scientists like myself, because we can help government figure it out. They are not in the business of interstellar affairs. And it would also obviously allow scientists to find more evidence in the spirit of what the government already found. So I very much hope that there will be transparency. I'm not sure why it's being hidden, if it is. It may also be that no such material exists, that it's all stories that are being told by corporations who develop the next level of weaponry, and they want to hide it under the rubric of extraterrestrial just so that nobody would take it seriously if they see it. But if it exists, I really want to see it.
Yeah.
And I'm not afraid of realizing that we have something to learn from someone else. I'm not afraid of any threat. I think that we do not pose a threat to species that are far more advanced than we are. We can just learn from them. I'm an optimist in this context. I disagree with what Stephen Hawking said a decade ago, that we shouldn't transmit any signals out of fear that they might see us as a threat. I don't think so.
You're also an AI optimist, which I thought was interesting. You'd written an article, and we'll let you go on. And we have many questions for you, but I just thought it was the article you wrote about AI, and there was some of this in Interstellar, which had to do with if something does come here, it might be like, you humans get out of the way. I want to talk to your AI,
Right, because they might feel kinship to our AI more than to us. Yeah. And it's unlikely that biological creatures would make the trip that takes millions to billions of years across tens of thousands of light years in harsh conditions, being bombarded by cosmic rays. To me, it makes much more sense there would be equipment, if it's functional, with a brain that is technological, AI. And our AI systems might help us figure out their AI systems. And it's just like watching your kids, work on the internet, and you can't really fully understand what they're doing, but you trust that they would follow your guiding principles. And I really look at the AI as our technological kids. And, the people that are fearful of AI, to me, are not good parents, because, they're worried about an intelligent system misbehaving. And, that's what kids are. And when you bring up kids, you worry about them misbehaving. But how do you avoid the risk? You don't expose them to dark corners of the street where there are lots of crimes taking place. So you don't want to train those AI systems on anything they find on the internet. You want to use training sets that, just like the education department decides about the curriculum of students, it's really the task of psychologists, the task of educators or philosophers to set the set of principles that we want to educate our technological kids, the next generation of AI systems. And it's an opportunity for the humanities. Rather than teaching ancient Greeks, as they did, for decades, I say, well, the ancient Greeks were interesting, but they didn't have computers. So let's shift the discussion from the past, thousands of years ago, about what people said back then, to the present and the future, and let the humanities tell us how to interact with intelligent technologies that we develop, because they are no different than humans in some ways. And we have to decide about ethical rules, about a set of principles that we want to train them on. And so it's an opportunity for humanities to be relevant. And I find it surprising that universities are not jumping at the opportunity. In fact, the only thing I see at universities is discussions about how much AI is allowed to be used by the students during when they do their homework.
Right.
That is not really the question. Okay.
Yeah.
The real question is, how should we foster a good relationship with our technological kids such that they will play a constructive role in society, so decide about the laws of ethics, the regulations, the legal system that you want to establish in connection to those intelligent. And, the same is true if we encounter extraterrestrial AIs. It will not be the work of physicists to figure out those systems, because physicists are used to figure out, lifeless objects that are not intelligent, electrons, protons, elementary particles that obey the same set of rules that are predictable, whereas it's psychologists and philosophers that deal with intelligent systems, humans, right? So if I were to witness an intelligent system from an extraterrestrial origin, I would likely bring psychologists into my research team rather than physicists, because they know how to deal with intelligent systems.
Fascinating.
Yeah.
Well, listen.
Well, I got to say, thank you so much for your time.
So grateful. Stay the course, by the way.
Yeah,
Don't
I
get
think-
discouraged by any of this. Please stay the course.
I hope,
This is
I hope
important.
the courage and curiosity that yourself and people like Gary Nolan, you're such a tiny group of scientists that are weighing in on this, and it's really invaluable for all of us.
Well, I jog
Yeah.
on my own alone with no people around every morning at sunrise, and I don't mind doing my science this way as well. But my hope is that it will get more crowded, and once it does, I will do something else.
and NASA's involved, and you've inspired. I think it's only cycling towards an exciting future. So
That's my
we're
hope.
really excited to hear about the next adventures of the Galileo project. We thank you again for taking your time with us, and hopefully we'll have the chance to speak with you again.
Yeah, great
Thank
pleasure.
you.
We look forward to seeing you on your talk.
Thank
Avi
you.
Loeb on Relay.